when we take measurements, we want to be able to say or extend those measurements to generalities about underlying system. So we use statistical methods to do so, to extrapolate from our measurements to the background system. And we're going to introduce a few parameters or terms used in statistics. In this slide we see values for height for people in different countries. So people in Japan say their heights are represented in this chart, and people in the Netherlands say their heights are represented in this chart. So we use these two charts to illustrate a couple of terms. First, we have the central tendency of those heights, and you can see the central tendency for the Japanese measurements and the central tendency for the Dutch. And the other term is dispersion. There's a bigger range of heights in this set than there is in this set, and that's the dispersion. So we have these two parameters that we're looking at, central tendency and dispersion. Now we also talk about a population. So a population is a set of elements, and here we have 12 elements. And we'll look at the central tendency for the population, which is called the mean, and the dispersion for the population, which is the standard deviation. Here's the way to calculate mean, which is given by or represented by the symbol mu. Mu is just the average value of all the elements. And the dispersion is called the standard deviation, and to calculate that we find the square of the residual being the difference here between the value and the mean. So, and then we sum those squares. So we take the sum of all the squares and then we average that sum. So the average squares, or average residual squares, and then we take the square root of that. Now what we'll usually work with is a sample. So we take some of the elements out of the population. If we wanted to find some trait of all the people in America, we couldn't measure them all, and so we would measure a sample and then use statistical methods to make conclusions about the population. So for a sample, we also have a central tendency, and here we have the arithmetic mean and the sample standard deviation. So we have different symbols whenever we're talking about a sample and a population parameter. Our textbook doesn't use these different symbols, it just describes them differently, so it uses different words, but it's pretty standard to use different symbols whenever talking about parameters for a population or a sample. So you can see the equation for the dispersion or standard deviation for the sample is a little bit different from the standard deviation for the population. This video concludes with a brief discussion about that difference. So why are we using n-1 here for the average of the square residuals? Well, first of all, just remember that capital S is an approximation for sigma. So the sample standard deviation is an approximation for the population standard deviation. We use all of our samples in the population, all of our elements in the samples to compute our central tendency for the sample. And what this means is that not all of these residual values, the difference between the value and the central tendency, not all of those are going to be independent for our sample. So there are n-1 degrees of freedom instead of n. You can think about this in a different way. Just look at the fact that the sample data tends to be closer to the sample central tendency than it does to the population central tendency. And if we divided this average, or if we divided this sum by n, then we would underestimate sigma. Remember, capital S is an estimate or an approximation for sigma. If we had multiple samples and each one had its own standard deviation, as long as we use this equation, then the average of those sample standard deviations is going to tend to the population standard deviation. So it's for those reasons that we use n minus 1 in the sample standard deviation. Now if we had a really large sample, then we could go ahead and just use n here because the difference would be really minimal. Or if we knew the actual mean for the population, so instead of xm, if we had mu here, but we still had a sample of measurements, then we would use n. Now in this, there were several terms introduced. We had central tendency, dispersion, standard deviation, mean, population, and sample. And all of these will be employed in future discussions.